So, hello, Mr. Guruprasad Arya. First of all, introduce me yourself.
Good evening, sir. My name is Guru Prasad Arya. I have completed my graduation in mechanical engineering from Virmata Jizabai Technological Institute, Mumbai, in the year of 2022. After completion of my graduation, I joined Reliance Industries as graduate engineer trainee in maintenance domain. Uh, wo- uh, for working there almost a year, then I left to pursue my MTech in Indian Institute of Technology, Hyderabad, in the domain of aerospace engineering. And currently, I am working on a project of experimental analysis and flow visualization of underwater high-speed jets.
Okay. So, currently, where you are working, like you are working on the project itself, or you are
Yes,
pursuing a
yes, sir.
master's?
Yes, I'm pursuing my master's. In the master's, now I'm in the second year, so I'm working on the project.
Okay, you are working on the project. Okay, fine, fine. Great. So, the very first question, okay, like you are already in the aerospace department, right?
Yes, sir.
So, you must be aware of the PSLV. What is that?
Yes, sir. It's a polar satellite launch vehicle. It is the vehicle used by the ISRO to launch the polar satellites. This is the kind of vehicle which we use to launch the polar satellite launch vehicles.
Okay. The next question I would like to ask you, the designing of aeroplanes, right?
Yes.
So, what are the consideration or what are the factors taken while designing the structure of aeroplane?
Sir, so designing of the structures, while selecting the materials, the main crucial factor is of the strength to weight ratio. For example, we use the alloys which have high strength to weight ratio, like aluminum alloys and titanium alloys. And then while designing, we take into consideration the loading considerations. So basically, on the wings of the aircraft, there will be the fluctuating loads and some of the static load acting. So we will be designing by considering all these type of loading.
Okay. Have you ever seen Vande Bharat?
Yes, sir. I have seen it in only
In the photos you have seen, right? Okay. So the structure of Vande Bharat is something like this, okay?
yeah.
Okay.
Yes.
Right? It is like jet plane or okay, like aeroplane.
Streamlined structure. Yes.
Yes, streamline structure. Why it is?
Sir, because to reduce the drag, so we tend to make the objects like streamlined. Because in case of Vande Bharat, we are talking about very high speeds, and at that speed there will be generation of very high drag. So if we use a conventional structure there, then there will be high generation of the pressure drag, and so the values of pressure drag will be higher. But if we make it streamlined, then the pressure drag reduces significantly, and the drag which will be there only that will be only skin friction drag. So to basically reduce the drag, we are using this type of structures. Like we see in bullet trains, these are more streamlined structures than this.
More streamlined, right?
Yes.
Okay. So you said about the pressure drag, right?
Yes.
What is the difference between pressure drag and foam drag?
Sir, pressure drag basically it is occurring only because of let's say there are the blunt bodies or the bluff bodies. In that case, there will be the shape is like the shape is not streamlined, and so there will be high generation of the drag. And in case of foam drag, the major drag is due to the interaction between foam drag.
So air drag, it comes under what?
So this comes under the skin friction drag.
Skin friction drag. Now what is that?
Yes. That drag is due to the interaction between the air and the surface of the particular structure. Because more the structure is smooth or streamlined, then the lesser will be the drag produced. Because if we can reduce the pressure drag by making it streamlined, but there will always be presence of the skin friction drag that we calculate by using skin friction coefficients.
Okay. Now suppose the train is moving, okay?
No.
The velocity of air is in this direction, right?
Okay.
Okay. So where will be the stagnation point?
Stagnation point will be at the here the nose of the structure we have drawn here, just at the nose point.
Nose point.
Yeah.
What do you understand of the stagnation point?
The stagnation point, the point at which the velocity will be zero, and that velocity is completely converted in the generation of the pressure.
Okay.
Basically, the pressure is zero, velocity is zero.
So are you aware of Navier-Stokes equation?
Yes.
Okay. So what are the forces being considered in Navier-Stokes equation?
Sir, in Navier-Stokes equation, we consider the frictional process, then the pressure force, then the friction mu friction force, then pressure force, the gravitational force, that is body force. Yes, sir. I'm able to remember the three forces now.
Three only. Can you write down the
Uh,
equation?
yes, sir. Equation will be here. Okay. Equation will be rho.
No, don't
Del.
write here. Write in your book.
Okay. Okay. Rho del del x plus plus x plus minus x. Sir, is it visible, sir?
Show me.
The one is the inertia force, that is equals to the component of the friction force, that is by there. This is the viscosity coefficient. Then this is the rho gx, that is the gravitational force, and this is the minus del p by del x, that is pressure force. I have written it for only one direction.
Okay. Great. Okay. Now I want to know about the Euler's equation, right? What are the factors which we consider in the Euler's equation and which we don't consider in the Navier-Stokes equation?
Sir, in Euler's equation, first we will not consider the viscous forces. There we only consider the pressure force, that the pressure force component, then the gravitational force, and the velocity component, velocity force component. Yes. There we don't talk about the losses due to the viscosity.
Okay. Fine. Okay. So draw what is stress and strain?
Sir, basically the stress is the resistance force generated in the material, and the strain is the change in dimension upon the original dimension, the ratio of the change in dimension upon original dimension.
Okay, great. Now draw the stress strain curve.
For mild steel material.
Mild steel material.
Yes, sir.
Okay. Just explain that.
Sir, basically, in this test and curve, we will get different points. First of all, we will get the proportionality element, where up to which the Hooke's law is valid. Then just near to the proportionality, we will get elastic limit. Then we will get upper yield point, then lower yield point. Then the ultimate tensile strength point, and then the fracture point.
Okay. Okay. Now you tell me one more thing. Like, okay. So what is more analogous in fluid mechanics, heat transfer and mass transfer?
Sir, can you repeat your question?
What is analogous between fluid, heat and mass transfer?
Fluid, heat, and mass transfer. Uh,
How we represent that?
Sir, for fluid and heat transfer, they use the Reynolds analogy,
Okay.
in which we relate the skin friction coefficient and the uh, heat coefficient by using the equation. So that I know about this Reynolds analogy only. I don't know about the mass transfer.
Okay. ठीक है. Now suppose this is your boundary layer. Okay.
Okay.
Okay. Now this is your thermal boundary layer.
Okay.
Okay.
The first blue one is the velocity boundary and the red one is the thermal boundary.
Yes.
Okay.
Where is the no temperature junction point?
Uh, what sir? What's point?
No temperature junction point.
No temperature junction point. Yes, I don't know about it.
Okay. Like what are the assumptions you take in the boundary layer?
Sir, basically for assumption in boundary layer to inside the boundary layer, there will be viscous effects are there present, and outside the boundary layer, the velocity of the free stream is almost equal to the 99% of the free stream velocity, and there will be the velocity gradient present inside the boundary layer.
Okay. Fine. We'll conclude your interview. Okay. So yes, Guru Prasad, it was nice interview. Okay. You have conceptual clarity. Okay. Your expression and everything is fine. Okay. I don't think so. You need to improve much more, but uh, take it, don't take it as a grant. But yes, I think so. You are going to be selected, but focus like in the what I have observed and what I have seen, like whoever has given the interview, they had said that rapid questions are being asked. Okay.
Yes,
And
yes,
there
yes.
are rapid questions are being asked. So don't become nervous over there. Okay. And like they are not asking about your MTech project, and but they are asking about the work experience. Okay. So if you are mentioning your work experience, so they are going to ask you the questions from there. Okay. Okay.
Okay.
I didn't ask. Okay. In the next interview, maybe sir will be asking you. Okay. Kuldeep sir.
Okay, sir.
Okay. Today was his turn only, but I had taken, not a problem.
Next interview I have scheduled for I said 24th. Yes, 24th of August.
The which slot is there? Okay. Okay.
Okay.
Very good,
Okay,
sir.
sir. Okay, sir. Thank you.
Welcome.